Hello, my simulation friends! I'm going to show you a very interesting application that I was working with a customer today, and we got to test several new designs using Discovery technology, so I think it's interesting to share with you since there has been quite a few times since I last shared anything new with you guys. So we got here an structure of LED, which is used for street illumination, and we can have different applications here. We can perform static structural analysis, fluid flow, thermal, and for this customer, thermal is the main goal. So let's start a simulation process taking the advantage of Discovery ease of use. So we can start by pressing here on simulation, and as you can see, I'm working with only half of the geometry because it's faster, it's easier to understand, I can see the interior of the device, and I'm going to select these faces that you can see now in the screen that are orange, and I'm going to apply a symmetry boundary condition so that we can make the software understand that we have actually on the physics a mirror of this device. Once I've done that, I can start setting my boundary conditions, and remember, since we are working on Discovery environment, we have no limitations. We can minimize all the environment and work with an extremely ease of use environment. So to start, let's apply here some boundary conditions. So as you can see, we got some LEDs here. If I hide some of these devices, you'll be able to see that we got here some components which we can apply some thermal effect regarding the heat key that occurs here. So I'm going to apply using my halo. I got several conditions I can apply: structural, fluid flow. We're going to focus today on the thermal side, so we can apply temperature, convection, heat, and isolate this region. I'm going to apply heat to these components. We're talking about a device that is about 50 watts. And once I've done that, once again, I can select to see all the components that we got here on the tree. And whatever, let's start simulation. It's so easy. We can start playing around, just simple as that, and taking into consideration some details for us to understand how our product works. So in a matter of 2 clicks, 2 definitions of my device, all other boundary conditions were defined as convection surfaces, and already we can see such results like maximum temperature, minimum temperature, and why not? We can create our own. There is no problem here to select all the components we got in this structure, create a new monitor, and define, for instance, an average temperature. And we can define here to each simulation process that we perform, how is the result going to behave? So how is my maximum temperature and my average temperature behave? And now we can start playing with a few things. The first thing we gotta pay attention are the materials associated to this design. We're working with structural steel. This is not the most common material here. So we can double click the structural steel, and we got several applications, several different materials, different alloys that we can use. And for instance, let's work here, I don't know, with some aluminum alloy random just to start. And by the way, if you see here we got this symbol on my materials, it's because I'm working with Granta connection, so we got a massive database of materials that can be used at Discovery simulation environment. Since I've done that, we can see that a few things changed. We can see that the maximum temperature dropped severely because aluminum is a material that has the ability to change more heat, and we can continue to pay attention on new stuff. For instance, let's create here a new monitor in all of the project, and let's watch how is the mass of this device. This is a very interesting case because we're talking about aluminum, and any decrease of mass that we can create on this design, it's money on our pockets. It makes our business better competitive in the market, and we can get best revenue. So we can start playing with a few things. For instance, what will happen if I change this thickness, for instance? If I reduce this thickness in 1 millimeter, what's going to occur? Well, we can run the simulation, just change the geometry. Discovery will update the entire simulation workflow for you. And we can see that my mass got a reduction, very small, because I did a very small modification. And we can see what was the change in temperature for this case. Very little, nothing really changed. I'm working only on the mass. Well, I can change other stuffs. So, if I start playing around with this model, I'm going to change a few things. I'm going to select this face. I'm going to apply a pull operation until this other face that we got here. Realize that for each CAD modification, each design change that I create, Discovery is updating automatically, instantaneously, and providing me pertinent data regarding this project. So you can see that my mass is presenting a reduction for each iteration that I create. We can summon this to other kinds of operation. For instance, I can maybe, I don't know, change the thickness of this surface. All I gotta do is move a little bit my mouse. I can press any values here on my keyboard, and once again the entire design is updated. If it's pertinent, if I'm interested in this kind of study, I can perform structural analysis to understand if this new device, this new design is able to work with the loads that are applied here. Okay, let's change now this storytelling a little bit. If I'm more interested in the thermal part of the simulation, okay, there is plenty stuff that we can create actually. In our first perspective, we can see that we got here the maximum temperature of 83 degrees. What will happen if we create an exercise where I wanna change this LED? I wanna change here using the same structure, the same dissipation system, but I wanna work with another product which will be, I don't know, 75 watts. So I'm changing the lamp, but I'm using the same design, and I want to understand how my overall design will work. Okay, we can see now that my maximum temperature changed a lot, while the mass got no difference. I only changed the boundary condition. And this is very important because this kind of equipment, it needs to have a good heat dissipation. So 100 degrees more, it's not interesting for this device to work with such high temperature. But I got here the amount of heat that I need for the illumination that is needed. So how can I change a little bit the design? Well, first thing that I can do is play around with the number of heat sinks. So we got 4 now. What will happen if we increase this number to 5? All I gotta do is change this number, press enter, the design will update itself, the simulation will start once again, and we get to try new values. So if I increase this to 5, 6, 7, we can play around, we can try different things and understand the impacts of those changes. At any moment also, I can select here a face like this one, and I can change the length of my heat sink. So I don't know what will happen if I increase this dimension in 2 millimeters. Okay, we can see now that I got a little more mass than before, but on the other hand, we got here a maximum temperature that is closer to 100. Amaral, why is this point here so different from the others? Because I just stopped the simulation and changed the results, so we didn't wait for the software to fulfill a full simulation. Well, let's continue to play with this model. So what else can I do here to change things a little bit? Let's say that I got a target. I want this to be smaller than 100 degrees. That's my target, my design target. I gotta change more things. So let's play a little bit more. What can I change here on this device? I'm going to increase this to 8. I want to work now with 8 heat sinks. Sadly, my mass will increase a little bit, but my heat exchange will be improved. And once we do it, we can see the results we got here. There was a massive change in temperature, and we got about 75 degree. Okay, I have reached my target, my thermal target for this application. Once I'm satisfied with this project, I can stop my simulation process, and now if I'm interested, I can increase the complexity here. I can easily send this model to mechanical and start testing new things and more physical data and pertinent simulation data that is needed or of the interest. So as you can see, there are several things we can change here, we can play with, and any doubt you have, feel free to reach out. Cheers! Until the next video!